Assalamualaikum and hi everyone. We are group 2 from EC2222A4 and in this video we will present about our mini project which is hydraulic jump. A hydraulic jump is a phenomena in fluid dynamics that happen when a fluid moving over a surface at a high speed and suddenly slow down, increasing in height and decreasing in speed. A rapid rise in turbulence and energy loss characterize this shift. It is frequently noticed in spillways, open water walls, and other hydraulic structures. Hydraulic engineers should pay close attention to the position and magnitude of jumps since they can have big impact on how the structures are built and function. The objective is to study the characteristics and behavior of a hydraulic jump such as its location, size and energy dissipation, and the information can be used to predict the performance of hydraulic structure such as spillways, canals, dams, and to design them for optimal efficiency and safety.
So let's move on to the basic concept. So what is hydraulic jump? Hydraulic jump refers to the rise in water caused by the transformation of the unstable shooting flow supercritical to the stable streaming flow subcritical. When a hydraulic jump occurs, energy is lost due to the turbulence flow. This is the example of the hydraulic jump diagram. So, what are the uses of hydraulic jump? Hydraulic jump is used to dissipate or destroy the energy of water where it is not needed. Otherwise, it may cause damage to the hydraulic structure. Secondly, it may be used for mixing certain chemicals like in case of water treatment plant. Thirdly, it may also be used as a discharge measuring device. A critical flow. What is a critical flow? A critical flow is one with the minimum specific energy. Critical flow is a flow that corresponds to critical depth. Subcritical flow. When the depth of flow in a channel exceeds the critical depth, the flow is subcritical or flowing or calm. The Froude number in this type of flow is Fr is less than 1. Supercritical flow. When the depth of flow in channel is smaller than the critical depth, the flow is supercritical or shooting. The Froude number for this type is Fr is more than 1. One of the formulas that we use in this experiment is the Froude numbers formula, which is Froude numbers is equal to velocity over the square root of g times d, where v is the velocity, g is the gravitational constant, and d is the depth of water. Next formula is specific energy formula. The specific energy formula is E equals to d plus v squared over 2g, where E is the specific energy, v is the velocity, g is the gravitational constant, and d is the depth of water. Next, we will find the flow rate by using the formula Q equals to AV, where Q is the flow rate, V is the velocity, and A is the cross-sectional area. Nextly, we will find the head loss. The head loss formula is head loss equals to D2 minus D1 cube over 4 times D1 times D2, where HL is head loss, D1 is upstream depth, and D2 is downstream depth. Next, we need to find the power loss. The formula for power loss is power loss equals to rho g q HL, where g is gravitational constant, q is flow rate, HL is head loss, and rho is density.
Hydraulic bench, sluice gate, point gauge, rectangular open channel, tailgate.
The first step to conduct the experiment is we must measure the width of rectangular of open channel by using the vernier caliper. The width of rectangular open channel is 7.76 cm. Next, we measure the height of sluice gate to 10, 20 and 30 mm and we screw the sluice gate tightly. And the sluice gate is positioned at the identified location in the rectangular of open channel and screw tightly to ensure the sluice gate not move. Next, we open the valve and control the flow of water. Then we close the dump valve and we must measure the flow rate by fixing the volume and set the time. Then we close the tailgate. After the jump stabilized, we measure the upstream and downstream water depth using the point gauge.
Here I will show you the sample of calculation. First, we need to calculate discharge of flow rate. The formula for discharge of flow rate Q is V over T. So we get V from this table 0.005 over T 6.87, and we calculate, we got 0.00073. So next, we calculate the velocity V1 and V2. So the formula to get velocity V is Q equals to AV. A equals to BD, so Q equals to BD1 V1. So we insert the numbers from the tables to the formula. Q equals to 0.00073 equals to B 0.075, D 0.0575, and we calculate, we got V1 equals to 0.1693. We also do the same steps for V2, and we got V2 0.1258. So next, number 3, we find Froude number FR1 and FR2. So formula for FR is V over square root G D1. So FR1 equals to V1 over square root G D1. So we put the numbers inside the formula from the table. V1, we got 0.1693 over square root G is equals to 9.81, and D1 is 0.0575, and we calculate it. FR1, we got 0.2254. FR2 is the same as FR1, so FR2 we got 0.1444, plus we calculate head loss and power loss. So head loss formula is D2 minus D1 power of 3 over 4 D1 D2. So we put the numbers from the table into the formula. Head loss equals to D2 0.0774 minus 0.0575 power of 3 over 4 D1 0.0575, D2 0.774, and we calculate head loss HL. We got 0.00044, and power loss is delta P. The formula is rho G Q head loss HL. So we put numbers into the formula. Rho we use 1000, G is 9.81, Q is 0.00073, and head loss is 0.00044. We calculate it, we got 0.0032. That's all.
Froude number is associated with the change of water depth and discharge in open channel. The results show the simulation of the experiment by varying the head of the sluice gate, which is 10 mm, 20 mm, and 13 mm at two different flow rate Q. By observing the result, the upstream conjugate depth decrease as the downstream conjugate depth increase at constant discharge, whereas an increment in the downstream depth is obtained as discharge increase at constant upstream depth. The Froude number at the upstream depth boosts as upstream depth decline that can be attributed to the increase in flow velocity. On the other hand, an achievement in upstream Froude number is achieved by increasing the slow discharge at constant upstream depth. However, the results for this experiment do not exactly correct. This is believed to be due to the incorrect placement of the point gauge during the experiment, which is caused an inaccurate water depth measurement. Since the calculation depend on the measuring depth, the error affected the value obtained. Therefore, this set of data should be considered as experimental error and not used to represent the actual behavior of the flow. As error for this experiment, incorrect placement of the point gauge resulted in incorrect water depth measurement during the experiment. Parallel error might be occur, so the eye must be perpendicular when reading the data. Precaution: ensure the point gauge is positioning correctly before taking water depth measurement. The tip of the point gauge must be just touching the water surface while taking observation. The head measurement needle must be adjusted precisely. Rate the scale at eye level to avoid parallax error. Take measurement at stable flow region and away from areas with high turbulence.
Consequently, it can be said that hydraulic jump is a circumstance in which the channel water level rises. This occurs when supercritical flow Froude number more than one transition to subcritical Froude number less than 1. and the supercritical flow encounter submerged objects like dam or weir, which causes the water to shoot upward. Hydraulic jump include energy loss in dams, channel, scouring prevention downstream of a dam, and reversing water flow and high water levels on the downstream side. Turbulence occur, which can cause channel erosion and degradation is a drawback of hydraulic.